Hey Ryan,
Hi,
how you doing, bud?
I'm good. How are you?
Good. Um, sorry. First thing, how did your quiz go?
I got a 92.
Okay, all right, that's fine. I won 100, so but uh,
I
yeah, I'll live with
mean,
that.
we're moving up.
Yeah, exactly. I'll live with that. I mean, you're like a very talented student, and so you could. No, I'm still not satisfied with a 92. But anyway, what can I help with today, and what are we like gearing towards? Yeah, what's the goal?
So I have a test on Friday,
Uh huh.
and it's on everything that we've been doing. So 5-1 through the last thing that we did.
Okay. Did he give you a review packet?
7 o'clock. No, he didn't. But there was one note sheet that I wanted to go over.
Sure.
Like it's like from 5-1 stuff. I'm sending it to you now.
Okay, beautiful. You can text it to me.
Yeah.
Okay, thanks. You had a good day?
Yeah.
Good.
How about you?
Good, yeah. Like, I think I slept too long on my like left shoulders. My left shoulders, like the athlete problems in short. So that's it. But and
Yeah, it's annoying when you just sleep in the wrong spot. And
yeah,
it's like,
I know. Sorry, and it probably is like I mean I'm a soccer player, so it probably that kind of stuff probably affects your type more than me. But yeah. Do you play every day?
um, I mean, during the season I'll play every day, but right now I'm playing 4 times a week and lifting every day.
Okay, jeez. Um, like I mean, where do you plan to take? Do you plan to like take a pro or where you?
Um, Not really. Like, I mean, I'm playing a pro tournament next week.
Yeah.
No, later this month. But like, I don't think it's gonna be like a thing that I'm gonna do like after college.
Okay. Yeah, I think one of the kids I tutored that I said is really good is like, his last name is Kingshot. His brother is Thomas Kingshot. I forgot his. Anyway, yeah, I don't know how tight that circle is, but he's also a lot older than you, so.
Yeah, I don't know that many people that are like that older, that much older.
Yeah, sorry. Um, Let me know if it's sent.
I
Got it.
Yeah, it is.
Okay, got it. Thank you. Sorry. Um,
It's just the trapezoidal stuff, like with the areas.
okay, gotcha. So this,
Um,
go ahead.
then the second problem is one that is the one that I like got wrong and got like a 2 out of 12 on the quiz.
Mm-hmm.
Um, Instead of like the trapezoid, he asked it for midpoint.
Okay. Yeah, like, but it's okay. I mean, it's like a combination of a lot of things, including him being out, blah blah blah. But these two are probably like the easiest of the things that we have done. So yeah, these are layups. Okay, so let's start. Let's start with the sorry. Let's start with the first one. Um, why don't you read it?
Um, Use the trapezoidal rule with four equal subdivisions to approximate the integral from 1 to 3 of x squared plus x dx. Is this approximation an overestimate or an underestimate of the actual value of the integral?
Okay, so you usually don't have to like um have a visual, but if the function is simple like this, get it right. Get a visual for the function, and like cause like really like there are other ways you can answer the question of is it an overestimate or an underestimate, but like if you have the visual, that's easiest, right? So like the function is f of x equals x squared plus x, right?
Yeah.
Yeah. So I mean, well, what's a way we can graph this? We could factor x and x plus 1 equals 0, right? And that would give us x equals, you can, I mean, this is algebra, so feel free to correct me if I make a mistake anywhere, but x, this is where we're at. All right, and then if we like erect our axes, like here they are, and sorry, so like we've got like -1 and then 0. I'm intentionally drawing an exaggerated graph so that whatever, like we could get our visual um easier to see. And so the integral It's concerned. Oh no, wait. Why did I draw it downwards? It's not downwards. My bad. It's upward. Okay. Yeah, we can try to figure out the minimum of the quadratic, but it's not important to our to what we're trying to do. You don't need to. So a rough sketch is usually good enough. Is what I'm trying to communicate there. Okay, sorry. So fine. Then what? Like four subintervals, right? So like, but I'm looking at the constraints for the integral. It's from 1 to 3. So actually, like like we drew where it's most convenient, but like where we need to worry is like on the right side of the x-axis from 1 to 3. So basically, it's the upward sloping part of the parabola where we're concerned. So fine, like let's say 1 is right here and 3 is right here. Figure not drawn to scale. So then we have this, and then we have like this, and now it says like for the trapezoidal rule, it says like to use 4 subintervals. So I guess we can say T4, right? So fine, like I mean just so that my visual is not deceptive, and these parts. Can you say with the concavity of the parabola, is it concave up or concave down in those parts?
Oh,
Yeah, definitely. So I'm saying like the way I drew too much of a straight line in that part because then the concavity piece will come into play when we're answering the question of underestimate or overestimate. So I'm gonna draw it a little bit better in that part. Okay, there. Get rid of some of these. Yeah, that's good enough. Okay, all right. So that just shows that like when I draw trapezoids, the trapezoids are gonna go above it. Anyway, it says 4 subintervals. The interval width is this. So if we divide it up into 4 subintervals, how wide is each interval gonna have to be?
um, 3/4.
Let's see. So we have the how long is the interval width?
Oh, 2, right?
Exactly. And so we could just go 2/4, and then that's 1/2. No worries. So each one of them, each one of the trapezoids is going to have a width of 1/2. Got it. So that means that, like, since we started at 1, the next landing point is going to be 1 1/2, which is also known as 3/2. And then the next one is going to be 2. The next one is going to be 5/2, also known as 2 1/2. And then obviously the final landing spot is going to be 3. Okay, so fine. I'll to make it stand out, draw these trapezoids in green. But hold on. So I imagine this session will be short, and that's okay. That's good. Only like that what you need. Okay. Anyway, so so here we are. So like again, in the future, once you do this enough, you won't have to draw like the trapezoids or whatnot. You won't even have to draw the function. But for now, do it. Because well, it might help you. Okay, so here I've got 4 trapezoids. Now, like I think like I handicapped you in the sense that like I talked about these things big picture instead of doing a specific problem with you the first time we went. So I'll take a little bit of the blame for the 2 out of 12 on this one. Um, sorry, because yeah, like I shouldn't talk about it so broadly. We should have done a specific problem and it would help. But it's a guarantee question on the AP. They'll ask you a question about this on the AP. Anyway, so it's pretty straightforward from here. Like a trapezoid looks like this. Usually, it's not sitting on its height. Usually, it's sitting on the longer of the two bases. If it's a right trapezoid, and that's what you're working with always in calculus, you're always working with a right trapezoid. So here, so this is the height, and that's equivalent to h right here. The delta x is the difference in the x, the quarter of the entire interval width. Otherwise, we have base 1 here, base 2 here. So the formula is the average of the bases, base 1 plus base 2 over 2 times the height. So base 1, and let's say I'm going to shade the first trapezoid that we have. The first trapezoid is right here. So base 1 is right here, base 2 is right here, the height is right there. So based on all that, can you tell me what I should write for the area of that first shaded trapezoid?
So the height of base 1 is uh, 2, right?
Yeah, exactly. And you could just, for now, you could just tell it, recite it in terms of f of 1.
All right, so f of 1 plus f of 2, f of 3 halves,
Mm-hmm.
over 2 times 1 half.
Exactly. I'll explain why it's useful to just generally write it in terms of f of blah, blah, blah. Anyway, well, yeah, the width is 1/2. That's right. So I'll write it there. Okay, go ahead. Continue. The next trapezoid.
Plus f of 3 halves plus f of 2
Mm-hmm.
over 2
Mm-hmm.
times 1 half.
That's right.
And then plus f of 2 plus f of 5 halves over 2 times 1 half.
Yep. And finalement,
Um, f of 5 halves plus f of 3 over 2 times 1 half.
yeah, exactly. Sorry. Um, all right, that's right. Okay, cool. Good job. Now, this is why I wanted you to write it in terms of f, because now we have a number of conveniences. There are things we could factor out. Talk to me. What am I talking about?
The 1 halves.
Yep. So there's that. There's something else that.
F of 3. No.
Yeah, sorry. I'll help on this one. So there are two types of 1/2s. The 1/2 from the delta axis, the width of each of the, like each of these guys. In other words, the conveniently equaled height of the trapezoids. So those are those 1/2s, and I think I forgot a 1/2 in this last one.
So 1/4.
Exactly, and then the divide by 2 from the averaging. So exactly. So we could take out a 1/4. Shoot, where do I write? Um, I don't know, like maybe right here. So, sorry, yeah. So like 1/4, and then once you do that, there are more conveniences. So basically, like let me get rid of. So these are out now. We've taken them all out as a 1/4. So then look at what we have. What else we have, and tell me some conveniences I'm talking about.
You have 2f of 3 halves,
Yep.
2f of 2's, and 2f of 5 halves.
Exactly.
And
Sorry. Go ahead.
the only things that are like not repeated are f of 1 and f of 5.
Exactly. That needs to always happen when you're doing the trapezoidal rule. Because, well, yeah, like the computation will be slightly different. The function will be slightly different. But the setup is going to be the same. So f of 1 and, f of the first number and f of the last number will be alone. Otherwise, every one in between will be repeated. So this is why you would have wanted to term it in terms of f of before you do the calculations. All right, so then I'll just write, sorry, f of 2 plus 2f of 5 halves, and then plus f of 3, all of this multiplied by 1/4. Whatever number you get here is the trapezoidal approximation. Now, I mean, we could sit and do it, but I don't think it's a good use of session time. What do you think?
Yeah, no.
Okay, good. All right, so let us move on to the next one.
Yeah, the next one was really what I was struggling with, because it's like, I feel like it's a lot harder to visualize with like the the column thing.
No, you're good. Okay, sorry. Read it out loud for both of us.
The velocity of a toy race car moving around the track is given in the table. Use the trapezoidal rule with 5 equal subdivisions to give the approximate distance traveled by the car during the 10 seconds.
Yeah, so first of all, I'm sorry, go ahead, continue.
Do you want me to read the column, or?
No. Sorry. No. So, like, what is it? First of all, like, just, so that we have our concepts, down, like, when you're doing a trapezoidal rule or midpoint rule or whatever, you're approximating the integral, the area under the curve, because the integral means the area under the curve. And the reason why we want to do that is because, well, like, velocity is the derivative of distance, or displacement, rather. And we talked about total distance last time. But anyway, velocity is the derivative. And so, well, since we need distance to go backwards, we need to anti-differentiate, which is take the integral. And that's why, big picture, that's why we are using guess estimating the area under the curve. Oh, I realized that we didn't answer like the tail end of the last problem. So was our once we finished computing, was it going to be an underestimate or an overestimate?
An overestimate?
Yes, because of the concavity, right? Because
Yeah.
yeah, exactly. Sorry. Because huh, what happened to the whiteboard? Okay, sorry. I think it's just in the background. Yeah, okay, whatever. Okay, yeah, so exactly. Sorry. I mean, I'm sure you get it. Like, I don't need to do this, but just uh, nail it down. Like, the quadratic looked like that. That's why we asked the concavity question. And so each of the trapezoids on their, like, slanted part, they looked like this. So they were overestimating it, albeit, like, barely. Okay, all right. So, getting back to this, yeah. So that's why we integrate, right? But otherwise, but like uh, this tabular way is just as easy. And actually, the AP rarely poses these questions the way the one is posed. They almost always do it the way that two is posed. They say use the trapezoidal rule with 5 equal subdivisions. Yeah, so that's the key word. Because if you look at your table, like it's got a lot of data points. And so then, wait, which ones do I use is the confusing part. It says use 5 equal intervals. All right, so this is pretty straightforward. If I'm doing it like too quickly, like stop me and I'll be like, all right, we need to slow down. But where does the smallest t value, which would have been the x-axis, right? Like the equivalent to the x-axis. What is the smallest t value and what's the biggest t value
Um,
for time?
0 and 10.
Yeah, exactly. 0 and 10. So that's the equivalent to the integral 1 to 3 that we had in problem 1. That's telling you the width of the interval. So how wide is the entire interval that we're working with?
10.
Yeah, exactly. 10. Well, they said use 5 equal trapezoids. So what does the width of each of them have to be?
2.
Exactly. So then you start at 0. Next landing spot is 2. So that's the first trapezoid. And you talk. And then continue. So the next one?
2 to 4.
Yep.
Then 4 to 6.
Yep.
6 to 8.
Yep. Exactly. That's it. So this is very easy, bud. So, okay. All right. So otherwise, I mean, I could draw one of the trapezoids if you like. We don't need to see what the actual graph looks like. And the quadratic was monotonically increasing, which is it was increasing at all places. But like, the function may do this, which is like the trapezoids may overestimate in some parts and then may underestimate it in other parts, or like they it's not even a matter of overestimation underestimation. Basically the trapezoids might not all be like going this way, right? It doesn't matter, we don't care, we don't need to visualize the function, we just need the values, the f values, like what you were saying, f of this and f of that earlier. We need those at these places. That's all we care about, right? So I'm saying you could work without the visual and do just fine. All right, so then this is pretty straightforward. You talk, and if I need to chime in, I'll chime in. Go ahead. So how should I proceed?
The height is 2 on each one, and you're dividing by 2. So
Yeah. So what is the? Let me help you a little bit. Sorry. Go ahead.
the 2 and the 1/2 should cancel out.
Yeah, we can work on that in a second. Yes, you're right. They will. Good job thinking ahead. Let me lead you this way. What is the function this time that we're kind of integrating, which is estimating the integral with? What is the function?
They didn't give us a function.
Yeah, they did. They named it. They didn't say it's f of the. They didn't give like variable expressions for it, but they named it.
The velocity?
Yeah. So at each place you're doing v of this and v of that instead of f of this and f of that. So now that you've got all the technology, talk to me. What should I write?
V of t.
Yeah. So let's start v of 0 plus.
Oh, v of 0 plus v of 2
Yep.
over 2
Yep.
times 2
There you go. Beautiful. So as you said, these are gonna cancel. Continue.
plus v of 2 plus v of 4 over 2
Okay.
times 2.
Yeah. I'm sorry. So can we skip on like so plus dot dot dot? What's the last one?
V of 8 plus v of 10 over 2 times 2.
Yep, exactly. Beautiful. So this is why I was saying that after you do this enough, you don't even have to really think much because now you gathered that the dividing and multiplying by 2 cancel. So all you have left in your calculation and your answer is v of 0. Go ahead. V of 0 plus.
V of 0 plus 2v of 2 plus 2v of 4 plus
Yep.
2v of 6 plus 2v of 8
Yep.
plus 10.
I'm glad I didn't talk in that part because I figured you got it. 2v of 6 plus 2v of 8.
So this same method should work for like the midpoint.
No, the midpoint would be the midpoint is super easy, right? So sorry. So all you're doing is the interval part, let's say your function looks like this, right? And so let's say that this is let's take the interval from 2 to 4, right? So what the midpoint is doing is instead of using trapezoids or left sums or right sums, which under approximate over approximate heavily, left sums and right sums, the trapezoid does a better job than either left sum or right sum, right? Right Riemann or left Riemann. But anyway, the midpoint is an in-between the left and right Riemann, right? So all you do is on each interval, the width of the interval would not change. It would still be 2. But instead of using the f value at the left end or at the right end, you use the f value at the midpoint. So if this is let's say g of x, then you for the first rectangle, what you would use is the height being right here, which is a little bit of over approximation, a little bit of under approximation. So you'd be saying f of 3. Sorry, that x is 3, but the interval width is 2. So you'd be f of 3 times the width of the interval in my drawing is 2, and then you'd keep going that way. So for example, if the velocity question if we were doing the velocity question using midpoint, then we would have said we would have still had width being 2 for the first rectangle, for the second, for all of them, and almost always you want to use equal widths, right? Whether it's a trapezoid or a rectangle. There are exceptions, and the exceptions real quick is of the table, for example, the velocity table you are given went 0 and then 3 and then 5 and then 9 and then 12. What they will tell you is use, let me see, 1, 2, 3, 4. They will say use 4 trapezoids suggested by the table. Meaning, since you don't have 0, 1, 2, and everything in between, the width that is suggested is 0 to 3 on the first trapezoid, and then 3 to 5, and 5 to 9, blah blah blah. Obviously, 5 to 9 is 4, whereas 3 to 5 is 2, so they're not equal. But that's in the instances, and the rare exceptions where they give you a table that's not complete, and they will say use interval widths that are suggested by the table, and usually they do this on the AP. So that's just a very early heads up. But coming back to the midpoint, right? So if we're doing the trapezoid question, the velocity question, using midpoint, again, the widths are equal. They're all 2, but then for the first rectangle, you'd be using the value of the height in the middle. So it would be v of 1 and blah, blah, blah. Make sense?
Yeah.
Okay, cool. Any questions?
Nope.
All right, but so I really liked that you got on this. I mean, it's very obvious you're a disciplined student, but I really like that you got on this early. For quizzes, we can get away with studying the day before. In fact, I prefer that because I want my voice in your head as you go into the class and whatnot the next day, fresher. But for tests, always do what you just did, which is let's get it a day early, and if we don't need to meet for long, we don't meet for long, and if you come up with questions the next day, then we have a day's cushion. Fair?
Yeah, I just have one thing
Sure,
that from quiz.
sure.
Um, I just sent you the question.
Okay, no problem.
So it was just question one.
Okay.
I feel like this should be easy. I just like kind of blanked and then I like kind of got it at the end. I'm not sure, but like
It's okay. So read the question.
let g of x equal the integral from 0 to x f of t dt, where f is the graph shown consisting of two line segments in a semicircle. Give the value of each g of 2 and g of x, and then there's part b and c.
Yeah, so g of two is like the integral from 0 to 2 of f of t dt, right? Since the graph that's given is that of f, that's just saying the area under the curve from 0 to 2. Well, that's just that little triangle. So its height is, yeah, fair?
Yeah.
Okay, and for g of 6, you would approach it similarly, and it would be like the area between the x-axis of that little triangle, since again, g is defined from 0 to x. So you have to start at 0, since the integral starts at 0 in your area interpretation. Anyway, you go from 0 to 6. Well, you've got the semicircular part to take care of now, and you need to keep in mind that the semicircular part is, finish the sentence?
What?
You need to keep in mind as you do g of 6 that the semicircular part is
Negative.
yes. Great. Okay, and what about b?
Give the intervals where g is decreasing.
Okay, well, so decreasing and increasing, how are those questions answered?
Um, well, it should just be wherever it's negative, right?
Wait, wherever what is negative?
Um, the where f of t is the graph, right?
Yeah, but like in terms of g, right? Because they're asking for g. So here, I'll just say it instead of making you read my mind.
Oh, so wherever the slope of g is negative.
Yeah, wherever the derivative is greater than 0, you're increasing. Um, and wherever the derivative is less than 0, you're decreasing. And and this is about g, so we need to take the derivative of g. Notice that the derivative of g, g prime of x, would have to be d dx, the derivative of the integral from 0 to x of f of t dt. And one of our lessons was all about the fundamental theorem of calculus. And so to take the derivative of the integral, what we said is just like, well, you just got to put this in there and keep chain rule in mind. So this is going to be f of x, right?
Yeah.
Exactly. So in the end, you are right. Like what you need to do is analyze like where f of x is below the x-axis, which is where is it negative for the decreasing part. But it's important to connect that to like, well, that's because f is the derivative of g, and they're asking about g decreasing, and so I need to look at the derivative of g. Anyway, answer the question now that we've said all this.
From 2 to 8.
Yeah. Technically, there's like one spot, like 6, but you were right in your answer. It's 2 to 8. Like this is really cool. This is probably like me being fancy, but like basically at that point 6, it's actually neither increasing nor decreasing because the derivative is 0, right? But you can't talk about increasing or decreasing at a point because like how can you increase or decrease at a point? You need some interval, no matter how small. So in the end, you include like if there are singular points and the interval where like it's 0, you include them like just like you did, and so you would report from 2 to 8 as you said. Good. All right, so we need to look at C, you said.
Yeah.
Okay, absolute minimum or absolute maximum. So minimums and maximums, obviously, like absolute minimums or absolute maximums require that we look at local minimums and local maximums plus endpoints. Now, so this is a very, very typical AP style. It's painfully obvious that Mr. Clark is trying to prepare you for the AP by making you do this question. It's literally like every year there's an AP question exactly like this. Anyway, so like for absolute minimums and absolute maximums, we need to look at the local minimums and local maximums plus endpoints. So how do we find the local minimums and local maximums?
You look at the slopes
And set them equal
at
to
0.
yes. Like, and notice you don't need to find, we don't care which is which. So it says absolute minimum value. Yeah, we don't need to identify if it's a min or a max. Like, let's just do, well, actually, maybe we should, because it said min, and so that will reduce our work, our calculation. All right, so we need to look at the local mins. First of all, let's draw a number line for G prime, which is F, and put on the places where it's G prime is 0. So where are those?
2 and 6.
That's right, 2 and 6. Good. So 2 and 6. But then since we're considering absolute, aka global minima, we need to also put on the endpoints. So that is 0 and 8. Got it. Now, of the numbers I put in between, which one is a min and which one is a max?
The max is 2.
Because you're saying it goes from positive to negative. Yep. And so, this will reduce our work. We need to consider 2 because we're looking for mins. Okay, and so what about 6?
6 is, well, never crosses the x, right?
Yeah, so you're saying like it goes from negative to negative, and so you're saying that it's neither a min nor a max, right?
Yeah.
That's right. That's called a saddle point, but you don't need to know. Like, basically, again, you don't need to consider it. Like, the reason we didn't consider 2 is because it's about a max, and the question is about the mins. The reason we don't consider 6 is because, like, the derivative doesn't change from positive to negative or the other way around. So the only thing we need to consider in this question looks like only the endpoints. So then, like, remember, we need local min. So what you do is, like, for global ones, you identify the local min and maxes, and then you calculate the function, the original function's value at those places, and compare its value at the endpoints. Since there are no local mins and maxes for us to compute the function's value at, we just only concern ourselves with calculating the function's value at the endpoints. So g of 0, that would be the integral from 0 to 0 of f of t dt, which is equal to what?
0.
Yep, and then the only other thing we need to consider is g of 8, which is the integral from 0 to 8 of f of t dt, and we don't know what that is, but I can guarantee you that the absolute minimum is going to be at g of negative 8, because if you look at your graph, the positive contribution from the small triangle in the first part is way outmatched by the negative contribution in the semicircle in the other triangular part, and therefore you're going to get a negative answer when you compute those areas in g of 8, so that's going to be less than this. So the absolute minimum is going to be at g of 8, and it's whatever value you will get when you add up those areas.
So if he's asking me for the absolute minimum value, I have to actually do the areas.
Say that again?
If he's asking for the value of g for the absolute minimum, I actually have to do the areas, right?
Yeah, exactly, because you need the function's value, and the function g is defined as an integral, meaning as an area.
Right.
Okay.
I think that's all the questions that I